we'll start with the first chapter, that is some basic principles of chemistry. Okay. Before starting with that, I like to discuss something about chemistry. So before we start, can anyone tell me like what exactly is chemistry? Not the textbook definition, but in general, what do you think? Like there would be something like you listen chemistry, so some things would come into your mind. So you can
The
share that.
chemical,
Sorry,
the chemicals,
chemicals. Yeah, perfect. Chemicals. What else? Study of chemical reactions. Perfect. Study of chemical reactions. Study of chemicals.
Atoms and molecules.
Atoms and molecules. Perfect. ठीक है. So like basic understanding तो है. तो चलो. ठीक है. I like to start things from right beginning. Like even textbooks में like let's say कि in textbook there is some concept and we don't have the background of it. So I like to go into the background as well. So there might be some things which I teach would be out of NCRT. So in that case, I'll write extra over there. So whenever I write extra, it means it is not there in NCRT. So there is a high chance that it would not come for NEET, but it is for your understanding. Okay, so when you revise after we complete our syllabus, no need to study that extra parts which you have mentioned in your notes. Clear? Shall we start? Okay,
Okay.
great, great, great. So what is chemistry? Now, before starting with chemistry, let's we know that it is a part of science. So what is science? Okay, so according to me, science is something or let's say a thing to explain what we see. Agreed? Science is a thing or a tool, a language to explain what we see. जो हम देखते हैं उसको एक्सप्लेन करना है तो वी नीड साइंस. तो थोड़ा सा साइंस के थोड़े से चीजें टर्म्स एंड ऑल लेके वी एक्सप्लेन इट. दैट्स व्हाट एवरीवन डज. वी कॉल इट hypothesis, then law, then uh, all those things. There are three branches in it: physics, biology, and chemistry. Physics and biology would be your respective teachers. Okay, Pushpa, Falguni, Ambika, they'll help you in that. My part is chemistry. Okay. Now, this whole science, that is physics, chemistry, biology, everything, is how we observe and explain. But to process the information, to come to a conclusion, to measure the observations and all those things, we need one more thing to process. Then, to process things, we can say, to process things or observations and predict results. How will you do this? Okay, no issues. It's maths. But again, I'll write basic as well. Okay, so advanced maths is not required, but basic maths, addition, subtraction, division, multiplication, thoda sa log, uh, that's it. And basic few basic formulas of maths. So, okay, so Snata will help you in this as far as I know. Okay, basic maths. So yeah, maths is a bit important. It's a language in which we can talk, we can say. Okay. Now chemistry. Let's start with chemistry. Right in the beginning, when chemistry was not even a subject, we can say, there were people who wanted to turn anything they can find to gold. You must have heard of them. They tried to convert lead to gold or anything they could find, and they wanted to create gold. These were one set of people. Another set of people who wanted to create an immortality potion. So basically, it would make people immortal. They won't die. These two types of people, we used to call them alchemists. And what they did was alchemy. I hope you're aware of these words. So even if not, then it's completely fine. But कुछ लोग थे जिनको कोई भी चीज मिली, पत्थर हो या लेड हो, कुछ भी हो, उनको उससे सोना बनाना था। दूसरे भी थे, उनमें से ही कुछ जिनको ऐसा एक दवाई बनानी थी जिसको पीने के बाद लोग अमर हो जाएंगे, डेथ नहीं होगा उनका। सो ये दो चीज के पीछे लोग पड़े थे, एंड वी यूज्ड टू कॉल देम alchemists. And what they did was alchemy. Can anyone tell me like what's the drawback, if you know? ड्रॉबैक बोल सकते हैं, और वी कैन से फेलियर, एनीथिंग. This is we can say medieval period, like before medieval period, we can say. At least give me one drawback or failure for this alchemy wale people. Acha, before we start, are you understanding like what I'm saying? Just give a thumbs up if you understand what I say. Nothing like that really existed. Okay, Harshita, could you elaborate like what did not existed? That is immortality.
As so both immortality as well as the stone which could turn all the metals into gold.
Right. But okay, let's leave immortality. But is it possible to turn anything to gold today?
It is by electroplating.
Electroplating, yeah, that is one thing. But I'm talking about changing one particular element fundamentally to gold. And if you look at it, there is one reaction, NP reaction. Again, we'll come to that as well. But we can change the nucleus of atoms. We can add protons and neutrons. Like today, science has developed a lot, chemistry has developed a lot, and it is possible to change the nucleus of, let's say, any one particular metal. We can add some protons and neutrons to it, and then we can get gold. So it is possible today, but at that time it was not. And again, it was a thought, and we cannot criticize it. But the drawback or failure that uh, they had was they tried to do, yeah, correct, nuclear reaction, like uranium breaks into krypton and barium. So basically we are changing uranium to something else. So कुछ तो होगा है, यूरेनियम krypton बन जाएगा है. तो it seems like magic, but हाँ ठीक है, we have studied a lot and we know that it is nuclear fission. Okay, so the drawback of alchemists were they tried to do these things, these things as in turn anything to gold or create immortality potion, Spiritually, they took or they used spiritual means or spiritual path to do this, and that was the drawback. Okay, again, I'm not criticizing spirituality, but it won't work if you want to convert something to gold or want to convert a medicine that cures everything. Okay, so this was the basic thing. Soon it was known that spirituality would not work, so people tried different things. Okay, so first we'll discuss what happened with those who were working for gold. For gold, as in turning anything to gold. What they did was they took thing one, thing one or substance one, they mixed it with thing two or substance two, then they did some things to them. Again, I'm trying to keep it as general as possible. So they took thing one, thing two, they mixed, or maybe they did some things to them, and after that, sometimes they would get new things. We can call it thing three. Are you getting it? They used to mix two things. कुछ तो भी करते थे और उनको कभी कभी ऐसा होता था कि कुछ नया मिल जाए. If you compare this, we can say this was A, this was B, A component, B component, or A compound, B compound, element, anything. These things, they did some things to them. We can call it conditions. Conditions to which A and B are subjected. And then sometimes new things form. So C. Looks familiar, right? A chemical reaction, we can say. Great. Now there was a problem. Let's say today I took कुछ भी ले लूं जैसे कि मैंने salt I took salt and sugar and then I started reacting them. First I put it in a box and then I compressed it. Maybe I heat it, maybe I burnt it. So I dedicated my 1 or 2 months on that particular thing by mixing salt and sugar. Many years passed. After few years, I thought I've did multiple experiments throughout my life, but then salt and sugar फिर से आ गया. So I started working on that again. There is a high probability. अच्छा, there is a chance that I'll remember it. But what about those who don't? जिन्होंने कभी काम ही नहीं किया है उस पे. For those who have not worked on that particular reaction, they will try to work on it again. So basically, time waste हो रहा है. And that's why just because few things or few conditions are not repeated, they started documenting things. They started to keep records कि अगर ये मिक्स किया तो what will happen, इसको मिक्स किया इतने टेम्परेचर पे तो क्या होगा. So all these things they started documenting. These documents, we can say books or papers. Okay, so these documents were passed on to future alchemists. So it was like you do not have to perform anything twice or thrice. If some things were already done, you can start from uh, like जो भी उसको मिला होगा उसके आगे से you can start. ठीक है. So in the quest for gold, they were not successful. So they were not successful uh, for gold, for gold as in converting anything to gold, but they like but we can say over the time they documented a lot of observations. Can you see like where it's going? If someone could explain, and then it would I would be like अच्छा लगेगा मुझे. Just what you understand from this.
That was starting of chemistry.
Yes, exactly. Even if you work on today, like let's say you want to carry out one reaction. So first thing what we'll do is we'll go to Google and we'll Google it. We'll get few research papers. There might be multiple research papers. You'll select one. You'll check the yield कि चलो अच्छा इसमें से 70% मिल रहा है इसमें 80% मिल रहा है. There might be one reaction which is 90%, but again it would have some costly catalyst. So according to our needs we'll select one research paper, and then we'll start uh, carrying out that reaction in lab or maybe in production if it's not patented. That's what they were doing. So even though they were not able to find gold, but they had a lot of observations ki if you mix this and this you'll get this, if you mix this and this thing at this particular temperature at this pressure then you'll get this. So that was the start of chemistry, we can say. Documentation of things. Next is for those who were in the quest of immortality. They tried and tested every possible thing on animals and humans and observed. Okay, so right now what we do is we call it clinical trials. There are some rules and regulations as well. Uh, and that's the same thing that was done in the medieval period. Every possible thing that people can get, they tried on animals, like what's the effect of it, as well as on humans. And they observed it and again recorded it. So right now we know like this particular thing is poison. This thing should not be eaten. ये नहीं करना चाहिए, वो नहीं खाना चाहिए, यही खा सकते हैं, वो नहीं खा सकते हैं. So some of the other uh, person must have died or suffered just so that we can know that राइसिन का intake नहीं होना चाहिए. ठीक है. Now in over the period of time when this trying and testing was going on, immortality was not achieved. No one became immortal, but effects of substances on animals and humans were known. This particular branch later came to known like it's we used to call it iatrochemistry. So chemistry we can say progressed, and this branch which was looking for immortality we started calling them like this branch as iatrochemistry. Okay, and this period was you need to check it, but 1300 CE to 1600 CE. Clear? है? If anyone has any doubt in this story, they can ask. Okay, so just to check, uh, can anyone tell me like what's the meaning of CE? When I write CE, इसका मतलब क्या है? Again, not related to chemistry or science, but still we must be aware of it.
Common era.
Common era. Perfect. When I was in school, we used to study BC and AD. Can you tell me like what's the difference between BC, AD, and CE, or what is common era? अच्छा, आप लोग ने BC और AD पढ़ा होगा ना? या आप लोग के टाइम से स्टार्ट हो चुका है वो CE एंड BCE यूज करना? Okay, no issues. BC was before Christ. AD, Anno Domini. इसका ही इक्विवेलेंट इज BCE, before Common Era, and AD we call it CE, Common Era. These are two different terms. ये जो terms थे ना, this were church terms. Christ है ना उसमें, that's why. And this CE and BCE, these are secular terms. It was a result of French Revolution. They started like they told that church should not interfere in all the social things. They should stay or stick to religion and do not interfere with politics and stuff. Church as in religion. So जितने भी religious जो लोग थे, priest, they should not interfere in politics or any other thing. So secular terms were introduced, and now I guess we use BCE and CE. क्योंकि वो तो change नहीं कर सकते, but we can change what we call. Okay, so secular terms. Now let's talk something about India. Ki, when people were doing this gold and immortality wala thing, what Indians were doing. I'll keep it very short. But if you want, you can read NCRT. It's like it has a lot of information. So Indians had a very vast knowledge, ठीक है, and it was passed on generations to generation. But documentation was not like possible or not there. ठीक है, so I'll just write Indians had vast knowledge of those previously two discussed things. ठीक है, chemistry and chemistry. We used to call it rasayan shastra, rasayanik vigyan, something like that. So Indians had uh, vast knowledge which was passed on generations, and its documentation. So documentation or writing things, it its documentation began around 1000 BC. Okay, so when medieval period was struggling, Indians were living a good life. Okay. Or 1000 BC is just a figure, maybe before. Okay, so, or maybe before that. Many artifacts have been discovered, uh, and the carbon dating proved that it is literally in the BC period, BCE period. Again, I won't go into much details, but who gave that atoms, like matter is composed of the smallest particle, and called it atom? पहला किसी ने दिया था कुछ theory? Who was the first one? First one. Okay, I'm asking a question. Who was that person who told that matter is composed of smallest indivisible particles and called it atom? Can't remember? Okay. At least you said Democritus. I'll look into it. but maybe क्योंकि वो thinker था. But like when we study NCRT, they told me that Dalton was the one, John Dalton. Okay. Now, Maharishi Kanad. Have you heard? In NCRT, they have written Acharya Kanda or Kannada. Maybe I don't know why they write it as Kanda. Maybe due to some of the other linguistic things. But Maharishi Kanad is what we studied. ठीक है? He was the first to give concept of smallest indivisible particles or particle. Molecules are known as anu in Hindi, and that's why he called atom perm anu or permanu, what we call it today. But perm anu, matlab first or the indivisible atom, something like that. So anu and permanu, these terms were given by Maharishi Kanad. He also gave few things. Okay, I'll just कितना पेज है 1 2 3. Okay, ठीक है, I'll write in the next slide. So Kanna told few things. First was the same thing. I won't write it again, but he gave the concept of smallest indivisible particle. He told that if you keep on breaking things, you'll achieve one particular point where matter would not be divisible further, and he called that thing as Parmanu or Parmanu. Apart from that, he said that that Parmanu can exist in doublet or triplets. If this is atom, doublet means like this: two atoms connected together, three atoms connected together, and these are anu. That means molecules, and they are kept together due to uh, some force. We now call it intermolecular force, or sorry, intramolecular force or bonds. Okay, but at least he gave this, and he gave this 2500 years before डाल्टन. 2500 साल पहले उसने ये बताया था. ठीक है, so we should appreciate it. Okay, great. Last thing, and then we'll start with our proper laws and stuff. Bhasma. Have you heard of it? भस्म या फिर भस्मा. Okay, great. Bhasma was created by like अभी भी होता ही होगा, but earlier it was created by tantrics and maybe priests as well, जिनको हम पंडित्स बोलते हैं. तो पंडित हो गए, तांत्रिक हो गए, बाबा. So they used to give this bhasmas for different types of diseases as a treatment. When bhasmas like the making or the production of bhasma was studied, like how it was made, we came to know that it contains metals, small particles. Apart from all the things, it has metals, small particles as well. ठीक है, and it was used for treatment. जो भी मेथड था, the methods that they used to create that those metal particles. If we do it today and study the size of that particles, we'll see that they are nanoparticles. Let's say gold. Can we use gold nanoparticles to treat some disease? If yes, then you can mention the name of the disease. If no, then तो कुछ नहीं. But I expect you to know this because you are biology students. You are aspiring doctors or future doctors. तो आपको पता होना चाहिए कि गोल्ड नैनो पार्टिकल्स किस चीज के लिए यूज होता है. Yeah, okay. Gold colloidal solution is given in intramuscular injection. Okay. For what? Again, gold colloidal solution. Gold colloids. Colloids are nanoparticles. Skin infections. Not sure about it. But one thing that I'm sure is cancer. It is used in the treatment of cancer. You will study maybe in biology or maybe in when you pursue MBBS. Okay. ठीक है. So yeah, that's it. With this क्राइसोथेरेपी. ओके, आई एम नॉट श्योर लाइक आप जितना बायो में जाओगे तो यू विल लूज मी क्योंकि मुझे बायोलॉजी उतना नहीं पता है. ओके, सो दैट्स इंडियंस इन अ नटशेल. देन एट वन पॉइंट alchemy died and iatrochemistry stagnated. ठीक है, एक जगह पे अटक गई, वो स्टैग्नेट हो गई. एंड वेस्टर्न मेडिसिन राइज्ड. ठीक है, दैट्स व्हाट यू आर aspiring for, western medicine. In the 1800s, I guess, or in the sometime when western medicine started rising, they started visiting India. Not just India, they might have visited Africa as well, but I'm writing India because it's given in NCRT. So they started visiting India, and hence modern medicine as well as chemistry. So modern medicine or modern chemistry started developing because we had extensive knowledge on what one particular thing would affect. We had Ayurveda. So Ayurveda was not a concentrated form of chemical. ठीक है, there might be some क्या बोलते हैं उसको इंग्लिश में, जड़ी बूटी को, आई एम नॉट श्योर. एनीवेज, लेट्स से कि कोई जड़ी बूटी है, उसके अंदर वी हैव केमिकल्स बट दे आर नॉट इन दैट मच concentration. So the effect of that particular plant would need maybe 1 or 2 months, since it is not in that much concentration. But people knew that this particular plant or root will treat this particular disease. That was shared with Western doctors, or not doctors, but oi, iatrochemists. And they came to know. They researched on it. They tried to extract that chemical, and today we call it API, active pharmaceutical ingredient. Most of the APIs are derived from plants, and then we work on it to make it stronger. Just like penicillin, it was derived from Penicillium notatum. Now we used multiple uh, antibiotics that are penicillin derived. Okay, so That's it. Chalo. Am I audible? Okay. So I guess this much is sufficient. Importance of chemistry. Chalo. Let's. यही था what we discussed. Just a minute. Any questions? Any thoughts? कुछ शेयर करना है किसी को? Like up till here, what we saw.
Okay.
Okay. Chalo. Nature of matter. It has few things, so there is no point in discussing in today's lecture. I'll discuss it in states of matter in pretty much detail. Like I'll start from uh, what matter is. Okay, so let's leave it. Next is properties of matter and their measurement. This will be covered in physics. शायद से discussion हो चुका होगा फाल्गुनी से. So he will teach this completely. Uncertainty in measurement, there are three topics, I guess. One is scientific notation. इसमें भी addition होगा, subtraction, division and multiplication. Second topic would be significant figures. इसमें accuracy and precision भी आएगा. So scientific notation, significant figures, accuracy and precision, and third is dimensional analysis. These uh, are there in physics as well as chemistry. So it's better if one particular teaches it. Like so, Falguni would do a better job. Okay, so uncertainty in measurement and units properties of matter nahi, but measurement and units and uncertainty. This all thing will be covered in physics. So I'll start with laws of chemical combination. Is everyone okay with this? Okay. इट्स फॉर योर गुड लाइक आपका ही टाइम वेस्ट होगा अगर मैं दो दो बार बताऊंगा. फिर ऐसा हो सकता है कि मेरा कोई एक अलग टेक्निक है और वो सर का कुछ अलग टेक्निक होगा. देन इट विल क्रिएट कॉन्फ्लिक्ट्स एंड whenever it's required I'll teach you small concepts if required. So let's start with laws of chemical combination, the very first foundation of our basic principles of chemistry. So first law is law of conservation of mass, and this law was put forth by Antoine Lavoisier in 1789. And he said, matter can neither be created nor be destroyed. Can anyone explain law of conservation of mass? You can give me an example of it. Like no need to teach, just take example de do. Even if someone goes wrong, I never tell them that they're wrong. ठीक है यार किसी का मजाक तो नहीं उड़ाऊंगा मैं मतलब. So you can interact. If you won't interact, then you won't ask questions. Uh, these topics are pretty easy, but there might be some topics which would be very difficult, and there might be some student who have has not understood what I have taught, but just because he is not interacting or she is not interacting, they won't ask questions, and they won't tell that ये clear नहीं हुआ है. And if they don't tell me, then I'll proceed. Okay, chalo. At least I got a reply from Aryan. Burning wood into ash. In chemical reaction, the number of reactants is always equal to the number of products. Number से अच्छा है, you can call it mass. Mass of reactants is always equal to mass of products. है ना? अगर 100 ग्राम कैल्शियम कार्बोनेट लेते हैं, if we take 100 grams of calcium carbonate and we heat it, it will decompose to give calcium oxide and carbon dioxide. But when you check mass, calcium carbonate, if it was 100 grams, you will get some value of calcium oxide, and whatever is missing, that amount would be of carbon dioxide. So mass would not change. Okay, so I'll just write a general thing. A plus B gives C plus D. If mass of A is 10, B is 20. So C अगर एक 14 है तो this has to be 16. 30, 30. Mass is conserved. Is it true like this law, or is there any limitation of it that you are aware of? Okay. Yes, someone wanted to say something. One more thing, you can discuss in Hindi, like it's fine. मतलब I'll teach in English, but if someone wants to have a discussion, they can choose their language. But make sure कि वो हिंदी या इंग्लिश ही हो. Okay. As of now, or as of today, we know that this is not 100% true, because there are some reactions where mass changes, because that mass gets converted to energy. Mass defect is also an example of it. Right, this is the Einstein's equation where he told that mass can be converted to energy and vice versa. And that's the equation. So in those reactions where mass is getting converted to energy, we cannot say that law of conservation of mass is valid. Okay, so but ठीक है. If you look at the year, it's 1789. So we cannot expect that mass defect and energy mass relation can be known. Okay. Next is law of definite proportions. And this law was given by a French chemist, Joseph Proust. And he stated that a given compound always contains exactly the same proportion of elements by weight. Okay. Confusing statement, but very simple thing. Let's consider any compound. Okay, let's take the NCRT one. CuCO3, cupric carbonate. Now there are two sources of CuCO3. One is a natural source and one is synthetic. Like we can make it. The percent, just a minute. So in natural source, if we check there will be some percentage of copper present in it, then some percentage of carbon and some percentage of oxygen. Now this is natural source. When we check the percent composition, when we have prepared it synthetically, it will still be the same. ये सब same होगा. That is law of definite proportion. That for a given compound, the elements that it contains will be in the same proportion by weight. And we know that if we change it, it will change. The like composition change किया तो compound will change. Clear? Same goes for water. Water, be it from anywhere, it will have two hydrogen and one oxygen. Definite proportion. If you take two oxygen, then it will become H2O2, hydrogen peroxide. So it will change. But जब तक पानी है, तब तक वो पानी ही है, चाहे कहीं से भी आए. Clear? Okay. Next is law of multiple proportions, and this law was given by John Dalton in 1803. And according to this law, if two elements can combine to form more than one compound, the masses of one element that combines with a fixed mass of other element are in the ratio of small whole numbers. Okay, I would not ask anyone to explain this, but I'll try to explain. Let's say we have carbon and we have oxygen. We mix them. Which compound will we get upon mixing carbon and oxygen?
Carbon dioxide, carbon monoxide.
Okay. So, chalo, I'll write carbon monoxide first and then carbon dioxide. Now, there are two oxygen. So, I'm not writing O2, I'm writing 2O. Okay, because right now we are in 1803. So, let's keep it that way. Now, you can see that two elements can combine to form more than one compound. Carbon monoxide, carbon dioxide. Two different compounds and elements are same, oxygen and carbon. The masses of one element that combines with a fixed mass of other element. If we consider the mass, let's say carbon we took 12, oxygen 16. In this case, in carbon dioxide, and you add it and you'll get this. So iska add karne pe you'll get 28. In this part, again, carbon is 12, oxygen 16, 16, 32. So 32, and this 44. Now you can see that carbon has a fixed mass, 12, 12 in both the cases. But ठीक है, तो ये fixed mass of the other element, one element that combines. So that is oxygen. In the first reaction, one oxygen combines with carbon. In other, two oxygen combines with carbon. So if we keep the mass of one particular element fixed, the mass of other two element or the other element would be in the ratio of small whole numbers. So we can say 32 upon 16, which is 2 upon 1. That's it. So इसमें कहना ये चाहते हैं कि one carbon combines either with one oxygen, or we can say one carbon combines with two oxygen. In both these cases, we will get different compounds. At that time, it was explained in this way. Today, it seems petty. Okay, let's check it once. Another example is of water. H2O, H2O2. Oxygen, hydrogen and oxygen, hydrogen and oxygen. Here hydrogen has two mass, one है एक का है तो दो का दो. Oxygen is 16. Here hydrogen 2, oxygen 32. Again, if you see, hydrogen has a fixed mass in both the compounds. So oxygen is combining in different ratios, and that ratio, when we divide the mass, that is 32 by 16, we'll get 2 by 1. So again, the ratio is a small whole number. I hope this clears it up. I know you know, but you need to know what the law says as well. Is this clear? Okay. Next is law of multiple proportions. We'll do one example and then it will clear up everything. You need to tell me what are the compounds when I mix nitrogen oxide, nitrogen and oxygen. Chalo, tell me what
Nitrogen
are
oxide.
nitrogen oxide, NO2. This is one compound. I need more compounds. ठीक है, NO2 तो हो गया. N2O, yeah, nitrous oxide. N2O5, okay. Dinitrogen pentoxide, N2O5. Acha, you must know that this is NO2 and there exists a dimer of it. We call it N2O4. ठीक है, but when you calculate, you will get the same ratio. So we'll keep it extra, but ये भी बनता है. That's it.
Nitrogen oxide, sir.
Nitrogen oxide as in NO.
Yes, sir.
Okay. And there is one more, which is N2O3, dinitrogen trioxide. Okay, so these 5 or 6 we can say are the possible compounds. So again, nitrogen and oxygen are combining with each other in multiple proportions to give different compounds. Let's make a list of it. So N2O, NO, N2O3, NO2, and lastly N2O5. Mass of nitrogen and mass of oxygen. So in the first, it's 28 and 16. Here it's 14 and 16. Here it's 28 and here it's 16. 3 से कितना होता है? 48. Okay, 48. So 14 and 32 and lastly 28 and 16 5 80. Okay, just so that I'll be clear, I don't know tables after 13. In fact 13 का भी नहीं आता है मुझे. So whenever I write, you'll have to tell me कि what would be the answer. ठीक है, क्योंकि मैं तो कैलकुलेटर यूज करता हूँ. बट हाँ, आपके नीट में कैलकुलेटर है नहीं, तो you'll have to multiply. Okay, now if you want to apply uh, Dalton's law, Dalton's law of multiple proportions, what's the requirement? If you look at it, the requirement is keeping one element's mass fixed, right? But as of now, you can see that uh, nitrogen ka we can fix. Oxygen would be a bit difficult, but nitrogen we can keep it fixed if we multiply NO by 2 and NO2 by 2. So let's do that. So let's make the changes here only. I'll write it in red so that you understand ki we have made some changes. So 28 and 28. So according to that, this will become 32 and this will become 64. Make sense? We wanted to make one components, one element's mass fixed. That's why we multiplied it by 2. Now upon multiplying, अब नाइट्रोजन जो है वो completely same हो चुका है. Now let's look at ratio of oxygen. First is 16. Let's divide it by 16. We'll get 1. Then 32. 32 divided by 16. We get 2. 48. 48 divided by 16. We get 3. Then 64. 64 divided by 16. We get 4. And lastly 80 by 16. We get 5. And you can use any other numbers. But as of now, I'm just checking. एक 16 ही ले लिया मैंने, simplest, and all other. So we're getting 1, 2, 3, 4, 5. So these are the proportions in which oxygen can combine with nitrogen. And in every different proportion, you will get a different compound. So that's the law of multiple proportion. जब एक ऑक्सीजन नाइट्रोजन से कंबाइन होगा बाय मास 1:, मतलब एक एक, तो यू विल गेट वन कंपाउंड. देन दो दो, तीन तीन, चार चार, इन दैट सेंस. अंडरस्टूड? Okay. These are very basics, but since it's there, we have to discuss. Next is Gay-Lussac's law of gaseous volumes, and this law was given by Gay-Lussac in 1808. And he observed that when gases combine or are produced in a chemical reaction, they do so in a simple ratio by volume, provided all gases are at same temperature and pressure. We'll discuss this when we study states of matter, gaseous state to be precise. But what he meant was, let's say we combine hydrogen and chlorine to form HCl. Now we know this has two hydrogen, two chlorine, so 2 HCl, stoichiometry, but at that time it was not known. So what he told was one volume of hydrogen will combine with one volume of chlorine to produce two volumes of HCl. And this is true for all gases, provided that they are at the same temperature and pressure. So simple ratio, what he meant by simple ratio was stoichiometry. Till at that time it was not known, but now we know. So if you make 100, combine 100 ml of hydrogen and 100 ml of chlorine, you will get 200 ml of HCl. That's it. And very similar to this, we had Avogadro's law, or you can call it Avogadro's hypothesis. So in 1811, Avogadro proposed that equal volumes of all gases at the same temperature and pressure should contain equal number of molecules. That is to say, keeping like at constant temperature and pressure, according to Avogadro, if we have 100 ml hydrogen gas and let's say it contains X molecules, at the same temperature and pressure, 200 ml of H2 gas will contain 2X molecules. 10 ml will contain X by 10 molecules. Now, when he gave this law, Dalton told that this is not true or this is not correct. And Avogadro's law did not become a law like others. It remained as hypothesis. After 50 years, it was proven that Avogadro was correct, and that's why we started calling it Avogadro's law. But it required 50 years, thanks to Dalton. Okay, so I guess we have finished with the 5 laws. If you have any doubts, if any particular law is not uh, explained properly, then you can ask. I'll try to explain it again. No doubts. Okay. Next is Dalton's atomic theory. This guy. So again, you must have studied. Okay, have you studied Dalton's atomic theory in school? Maybe in ninth or tenth standard? Like just asking. 11th 12th में तो पढ़ा ही होगा. But have you studied in school? Because I am not sure what's the syllabus of 10th standard. Yes. Okay. Thank you again. So that means you have studied. All of you must have studied Dalton's atomic theory. Okay. So only these four postulates are mentioned in NCRT. So we'll only study these four. No need to go in depth because anyway, it's not correct. Now, I want you to tell me like what are the drawbacks or limitations. First statement says matter consists of indivisible atoms. Can anyone tell me like why this is not correct?
So atom can be further divided into electron, proton, and neutrons.
Perfect. Now I'll start from like when I was in school. So they used to tell that protons, neutrons, and electrons. These are the components of atoms. So when he said matter consists of indivisible atoms, it was not true because even atoms are made up of protons, neutrons, and electrons. After that, upon further research, we came to know that even protons and neutrons are not fundamental. Fundamental. We have quarks, we have leptons. These two are known as firm ions or fermions. Fermions. Then apart from quarks and leptons, we have bosons.
Gluons.
Yeah, bosons are also of two types: gauge bosons and uh, sca- scalar
Higgs boson.
bosons.
Higgs boson.
Higgs boson, yeah, you can like उसमें भी हम जा सकते हैं, but it would come in these two types. Either it would be gauge or it would be scalar. But bosons are also uh, part of these things. Okay, so we can subdivide even protons and neutrons further. So again, matter consists of indivisible atoms was not true, but ठीक है, उसके टाइम के लिए हिसाब से तो ठीक ही था. Next statement is all atoms of a given element have identical properties, including identical mass. And next is atoms of different elements differ in mass. Can anyone point out the problem in the first part of the statement and then point out the problem in the second part of the statement? I have divided it. All atoms of a given element have identical properties, including identical mass. Okay. He didn't define isotopes. He did not knew about isotopes. So even though atoms of a given element might have identical properties, there is a chance that they don't have identical mass. And this is true because we know isotopes exist. So isotopes have identical chemical properties, but they don't have identical mass. And that's why physical properties might change slightly. What about those? The next statement atoms of different elements differ in mass. Is this part correct?
No, sir.
Isobars. Perfect. Isobars. Isotopes में we can write carbon 12, carbon 13 and carbon 14. In fact, carbon 14 तो identical properties भी नहीं दिखाता. It is radioactive sort of thing. It decays. Isobars, there is a possibility that two particular elements will have same atomic mass, but they'll differ in atomic number, that is different number of protons. For example, argon 40 and calcium 40. Both have same mass, but different atomic numbers, and that's why they are different elements. Okay, so isobars and isotopes can counter the second postulate. Third postulate is compounds are formed when atoms of different elements combine in a fixed ratio. Can anyone point out what's the problem in this statement? Because to some extent it is true, but what's the problem?
Sir, monoatomic compounds exist.
Monoatomic compounds existed, हाँ ये तो बोल सकते हो, helium and these all things. But at that time, okay, चलो आपने monoatomic बोल दिया है, तो I'll explain. Compounds are formed when atoms of different elements combine in a fixed ratio. Different elements. That is to say, according to Dalton and most of the scientists in that era, two different elements can combine. Like H and O will combine to form H2O. Okay, atoms of different elements. But hydrogen cannot combine with hydrogen to form anything. So atoms only of different elements can combine. Of the same atoms do not, because according to them, elements are exist in monoatomic form, like helium, hydrogen, nitrogen, oxygen. All this exist as a single atom. Today we know that hydrogen is H2, oxygen is O2. At that time, it was oxygen is O, hydrogen is H, helium is He. In that sense. So we do not used to call it, like we won't call it hydrogen molecule. It would be hydrogen atom. हाइड्रोजन गैस में हाइड्रोजन एटम होते हैं, बट टुडे वी नो कि हाइड्रोजन गैस में हाइड्रोजन मॉलिक्यूल्स होते हैं. Understood? This was one part. Other part was compounds are formed when atoms of different elements combine. What can you say about this? Calcium oxide combined with carbon dioxide to form calcium carbonate. In this case, two molecules are combining, or two compounds are combining to form a different compound. So not just atoms, even molecules can combine with each other. ठीक है, पर फिक्स्ड रेशियो तो सही था कि हाँ, फिक्स्ड रेशियो तो लगेगा. Okay, last is chemical reactions involve reorganization of atoms. This is true. But then he says these are neither created nor destroyed in a chemical reaction. Okay, so we have seen nuclear reactions, nuclear fission. In that, atoms are being destroyed and there are new atoms forming. So first part is correct. Chemical reactions involve reorganization of atoms, but they can be destroyed in, or they can be created as well. In fusion, it's being created. In fission, it's uh, destroying or being destroyed. Is this clear? Just remember these four postulates and what's the counter of it. Counters are very important, like uh, limitations of it. Okay, because there can be a question which would ask like this was the postulate and why it is not correct, and then they'll give you four options. So you should accurately like determine properly like what would be the most appropriate reason. So remember it. Shall we proceed?
Yes, sir.
Great, great. Okay, few things and then we'll stop. It's atomic mass and like formula mass would be the last point. So hydrogen, being the lightest atom, was arbitrarily assigned a mass of 1 without any units, and other elements were assigned masses relative to it. So before 1961, mass of hydrogen was 1, and then other elements had mass relative to hydrogen. So if we used helium, it would be 2 because helium had a mass of 2 times of hydrogen in that sense. But then there was a standard introduced and it was based on carbon 12. Okay, so what they did was they defined new atomic mass. They took carbon 12 isotope, which is the most abundant form of carbon. They measured mass of carbon 12 atom. It was possible. We'll see in the coming lectures how can we do this. Like not experimentally properly, itna padhenge nahi, but it was possible to determine mass of an atom. They measured mass of atom and then they divided it by 12. And whatever the value we got that was in grams, we named it 1 AMU. And AMU stands for atomic mass unit. And when this definition was implemented, mass of hydrogen became 1.008 AMU, or we can say U. U is unified mass, and AMU is atomic mass unit. And this is the value. 1.66 into 10 raised to minus 24. When we'll start with mole concept, I'll tell you ki how we got this value. As of now, just remember ki mass of one atom of carbon 12 divided by 12, whatever value we get in grams, we call it one atomic mass unit. Clear? Okay, great. Now my question is why again ये 1.008 है but we call it 1. Oxygen, if you will see, it is 15.999, but we use 16. But that's not the case in chlorine. We use 35.5. Can you tell me why? Are you aware that chlorine ka molar mass or molecular mass, it's too big to neglect. Okay, but what's that big? Like, what's big? Okay, just to point 0.5. Okay, just so that you know, 1 AMU, one atomic mass unit can be said as mass of one nucleon. What is nucleon? Unmute and tell, or you can text.
Either proton or neutron.
Correct. So proton or neutron. If you take one proton and if you want to determine its mass, you can measure it, but we call it 1 AMU. Same goes for neutron. Have you ever heard of half neutron or half proton? I hope not. So whatever mass you get is due to protons and neutrons, and each have 1 AMU mass. So why is that chlorine has 35.5? Because there is no way that it will have zero point 0.5 nucleon. It's the average of isotopes. Exactly. That's what I was expecting. There are two different isotopes. In case of carbon, the atomic mass that we use is 12.01, I guess. So it does not make that much of a difference. We'll see. Okay. So for practical applications and calculations, we don't use atomic mass, but we use average atomic mass. Average atomic mass is for definition purpose, many naturally occurring elements exist as more than one isotope. For example, carbon 12, carbon 13, and carbon 14. All these three isotope exist. In fact, there are many more, but ये तीन का significant proportions में present है. There is a chance that you will have carbon 15 as well, or maybe carbon 16 as well, but in very small amounts. When we take into account the existence of these isotopes and their relative abundance, that is percent occurrence, the average atomic mass of that element can be computed. So for that we need to know the percentage composition or percentage abundance or relative abundance. Now first we'll write the mass. So carbon 12 has a mass of 12 AMU. Carbon 13 has a mass of 13.00335 AMU, and carbon 14 has 14.00317 AMU. If you go for the percentage abundance, it is 98.892% for carbon 12, 1.108% for carbon 13, and 2 into 10 raised to minus 10% for carbon 14. Now to calculate this, just a minute. Can anyone tell me like how you can calculate the average atomic mass?
So by adding them and then dividing them by 3.
Adding them and dividing them by 3. But when you do this, adding as in, will you take this percentage as well or just the mass? It's fine, no issues. Like you can tell कि आप सिर्फ mass ऐड करने वाले थे या आप percentage को भी use करने वाले थे?
Mass multiplied by percentage.
Mass multiplied by percentage. Okay. That's the correct approach. Again, if you add 12 plus 13 plus 14 and divide it by 3, that means you are considering कि 33.33% is carbon 12, 33.33% is carbon 13, and same 33.33 is carbon 14. Sub 1:1:1 ratio में है. But that is not the case. So I'll just show you one method and then you can solve all the questions from the app, which are of these type. Carbon 12 atomic mass 12 AMU multiplied by 98.982 divided by 100, because we want to calculate that much percent contribution of 12 AMU carbon. So you'll get कि 12 atomic mass unit में से how much is it contributing in the average atomic mass? So we can calculate that mass. Plus 13 into 1.108 divided by 100 plus 14 into 2 into 10 raised to minus 10 upon 100. Upon adding all this, you will get a total value, and that value would be equal to 12.011 AMU or 12.011 U, and that's the average atomic mass, AMU. Is this clear? Okay, try this one. Sure. Chlorine ka like I know I can even tell you to calculate the percentage, but we don't have that much time. So there are two isotopes, chlorine 35 and chlorine 37. This is 75% abundance, and for 37, it's 25% abundance. Calculate, calculate the average atomic mass. Just see whether that method works or not. Just give a thumbs up if that method works and you get answer as 35.5 AMU. Okay, it will work. Pretty basic calculation. Now, when I say molar mass, what would be the molar mass of chlorine? Is there a difference between atomic mass and molar mass? Anyway, I'll discuss it in mole concept, but I just wanted to know whether you know or not. Anyone? — 63.5. See, I've written ki molar mass of Cl. What you have said or given is molecular mass of chlorine. So when you consider chlorine as a molecule, it will be Cl2. In that case, we won't call it atomic mass, we will call it molecular mass. And molecular mass would be equal to 35.5 और फिर जो भी आप add करके whatever you will get, which is I guess 71 AMU. But still it will be AMU. Molecular mass when it is for a molecule, atomic mass when it is for an atom. But when we say molar mass of Cl or molar mass of Cl2, we'll write the same thing. Molar mass of Cl is 35.5 and molar mass of Cl2 is 71. But the units would be gram per mole. Gram per mole. Atomic mass, molecular mass. Both will have unit as AMU because when we say atomic mass, that means mass of one atom. Mass of one atom, atomic mass. Mass of one molecule, molecular mass. But when we say molar mass, it means mass of one mole of that substance. So it can be atom, it can be molecule, it can be anything. When I say molar mass, that means uh, mass of one mole of that substance. That's why the unit is gram per mole. because it is in grams. तो क्लोरीन का एटॉमिक मास है 35.5 mu। आप उसका 1 मोल ले लो तो उसका हो जाएगा मास 35.5 ग्राम। इज दिस क्लियर? The difference between molar mass, molecular mass, and atomic mass. In schools or colleges, we used it like कैसे भी use कर लेते थे, but we should be aware like what the meaning of that term is. Why would we have three different names for one particular thing? Right? Makes sense? Okay, chalo. Molecular mass. Molecular mass is the sum of atomic masses of the elements present in a molecule. It is obtained by multiplying the atomic mass of each element by the number of its atoms and adding them together. This particular molecule shape looks like methane. ये बीच में black carbon है and side में white hydrogens. You know, atomic mass of carbon is 12, hydrogen is 1, but since there are 4 atoms, we'll multiply it by 4. So 12 plus 4, 16 AMU. This looks like water, H2O. Hydrogen 1, but since there are 2 atoms, we'll multiply it by 2. Oxygen 1, we'll add 16. So total 18 AMU. This is molecular mass. Again, if you want to write molar mass, then it will be 16 gram per mole. Then molar mass for water 18 gram per mole. ठीक है, ये molar mass हो जाएंगे. I don't think we should discuss this further. Last is formula mass. This is the last concept. I'll just read it once and then I'll try to explain. So formula mass is some substances such as sodium chloride do not contain discrete molecules as their constituent units. It may be noted that in sodium chloride, one Na plus ion is surrounded by 6 Cl minus ion and vice versa. That is, one Cl minus ion is surrounded by 6 Na plus ion. The formula such as NaCl is used to calculate the formula mass instead of molecular mass, as in the solid state, sodium chloride does not exist as a single entity. For example, if we can consider methane, we know methane molecules in gaseous form, there will be one molecule that looks like this. एक individual molecule होगा ऐसा. So we can say that it has a molecular mass of CH4. ये उसका एक molecule है, ये उसका molecular mass है. In water, same thing. We can tell that this is H2O and this is the molecule. Even in ice, we can tell that this is a molecular formula, H2O, because in H2O, other molecules are attracted with like each other due to intermolecular force of attraction. So there is a difference between chemical bond and intermolecular force of attraction. Do you agree? Again, we have not studied it as of now, but I hope that you know कि there is a difference between a chemical bond and a intermolecular force of attraction. Okay, so we can say कि जिनके बीच में सिर्फ bonds है, that is a compound, and that would be the molecular formula. This is not the case for Na plus and Cl minus. Na plus will have a ion, Cl minus is also an ion. This is cation, this is an ion. Both of them will have a force of attraction, and that is electrostatic force of attraction. This we call it ionic bond. We'll see, we'll study in chemical bonding. Now, this Na is not only forming ionic bond with Cl minus of like which is to the left, but to the right as well, to the up, to the down, to the front, and to the back as well. So now that molecular formula ceases to exist. I hope you're understanding. So we express them in the valency, like cross valency method. Ki Na has one charge, Cl has one charge. Both are opposites. So if we take one positive and one negative, if we add them, it will become neutral. So using that theory, we call it formula mass because telling molecular mass as NaCl would not be correct. So formula mass है क्योंकि हमने formula से निकाला है. If we select one crystal तो Na6Cl6 ऐसा होगा. And then we divide it. So NaCl हो गया. Again, very simple concept. थोड़ा सा complicated है क्योंकि समझाने का try किया है. If you get it, then it's fine. If not, then you can use molecular mass term as well. But if this comes in NCRT, then you must be aware ki what's the difference. And if you have looked at the recent papers, you'll see that out of 45 or 50 questions, 25 तो definitely theoretically थे. Like if you have read NCRT, you would have answered it. Hardly कुछ calculation या concept apply करना था. मतलब obviously concept पता होगा तब याद आएगा. But ठीक है. Next part is mole concept. We'll continue with this tomorrow.